Alright, hello Trig. So today we're looking at the quotient rule. So product rule, now quotient rule. So it's on the same pages, but different stuff. And again, if you're looking for a little rundown of how you get the quotient rule, that's on page 155 in your book. So go ahead and check that out if you're curious. There's a little proof there that I didn't think was worth writing out on all the little whiteboards when you're probably just going to skip over that part of the video anyway. So the thing you probably actually want to jot down is the quotient rule, which looks like this. So if we want to find the derivative of something and we've got a fraction in it, you're taking the derivative of the top of your fraction times the bottom of your fraction minus the top of your fraction times the derivative of the bottom divided by the bottom squared. So that's just something you're probably going to want to jot down if you didn't already pause the video and do that. Because again, once you've got that, most of this is just plugging things into the right spot. Okay, and I'm going to write small here so that it doesn't go off my board like it did the last time, which is why I had to go back and redo this. So, if we want f prime of x, we've got the derivative of the top, so that 2 is going to hop out front, so we got 2x minus 4, and again that 1 hops out front, but 1 times 4 is just 4, times the bottom, minus the top, so x squared minus 4x plus 2, times the derivative of the bottom, so the derivative of 5x is just 5, and then I'm going to rewrite that minus square root of x is minus x to the 1/2. That 1/2 is going to hop out front. X to the, and then 1/2 minus 1 is negative 1/2. Almost. Almost actually fit on the board there. Okay, and then we want that divided by the bottom squared. Okay, and there's our derivative. So most of this is just plugging things into the right spot. And again, if you really, really, really want to go through and FOIL all of these back out, okay, I'm pretty sure even the back of the book didn't do that, so I wouldn't bother unless it's something that's going to come out nice, which this won't. Alright. Now, same sort of thing as before. If we want a line that's tangent to this graph, first thing we're going to want is our derivative, then we're going to plug it in and find our line. So if we want the derivative of this, we've got the derivative of the top, which is just going to be 1, which is nice, because there's a 1 there. If that's not there, 4 is gone, 1 hops out front, times the bottom, minus the top, times the derivative, don't say derivative 10 times fast, derivative of the bottom, which is 1, over your bottom squared. Although really those 1s aren't doing anything. So we can just do that. And then if we want a line that's tangent to that at x equals 0, we're just going to go ahead and plug in 0. 0 minus 9 is negative 9. Minus 0 plus 4 is 4. 0 minus 9 is 9. 9 squared is 81. That one's a 9, that one's a 4. I shouldn't have used 9s and 4s in the same equation. Negative 9 minus 4 is negative 13 over 81. Okay, so that's our slope. So then we're going to take our slope and we're going to find our point. So we're going to want to plug 0 back into the original, find our point. So 0 plus 4 is 4. 0 minus 9 is 9. So we get 0, negative 4/9. So then we're going to take that point, and we're going to take that slope, so we get a point at 0, negative 4/9. And we got a slope of negative 13 over 81. And, I mean, you can turn those back into decimals, but why? Because they're not going to be nice decimals, so we're just going to leave it like this. And then point slope form, so y is our slope. X minus and then a negative, so plus that 4/9. Nope. Minus x1, which is 0, minus that 4/9. xy. Okay. And then technically that 0 is not really doing anything, so that can go away. So now technically we also have slope-intercept form if we want it. So there's our line that's tangent to that graph. And anything that's tangent, feel free to go through and graph it and see if it looks like a tangent line. If it's a tangent line, it should touch your graph at that point and not go through your graph again. So feel free to double check those by graphing them and seeing if it looks like a tangent line. Alright, one more thing. And last thing is a thing that looks like we should probably use the quotient rule, but there's actually a simpler way to do it. Because if we think of this as an x to the 1/2 instead of a square root of x, since that's the only thing on the bottom, we can split this up and say this is an x squared over an x to the 1/2. None of my markers are working. Plus a 2x over x to the 1/2 minus a 3 over x to the 1/2. So this is really just x squared over x to the 1/2. If we're dividing things with exponents, we're subtracting the exponents. So this is x to the 3/2 plus x to the, 2x to the 1/2 minus 3. And if it's on the bottom, I'm going to call that x to the negative 1/2. And then now we can take the derivative of that. And really the big thing here is just remembering that we still need to take the derivative of that. This is not the answer. This is just another way of writing this. So then if we want the derivative, that 3/2 is hopping out front. 3/2 minus 1 is 1/2 plus 1/2 times 2 is just 1. So 1/2 minus 1 is a negative 1/2. And then minus, but then also this minus. So that's going to turn into a plus. 3 times 1/2, I'm just going to leave that as 3/2. X to the end negative 1/2 minus another 1 is a negative 3/2. And there we go. Now, if you went through and you used the quotient rule for that, it's not going to hurt anything. You probably won't end up with exactly this, but you'll probably end up with something that's the same thing as this. So if you went through and did the quotient rule and the back of the book did this, just a heads up that they might not look exactly the same, but they're still the same thing. Alright, so go ahead and check out the homework in the description below, and I'll see you in the next video.